Hey guys, this is your lecture video pertaining to the molar volume of a gas experiment, and in this experiment we're going to be obviously determining the molar volume of hydrogen gas at standard temperature and pressure. So I'm going to go over just a little bit about how you go through solving for this. And so the first thing is that you have to understand where the hydrogen gas is coming from, and that is from the balanced equation that you see right here. And so we're going to be using magnesium and we're going to react it with hydrochloric acid. In doing so, we're going to form hydrogen gas as a product. And so what we're going to do is we are going to use a eudiometer. Now in the procedure in the lab it talks about using the burette, but we actually have a eudiometer that I use in this experiment. And eudiometer is a way that you can measure the volume of the gas that is trapped. And so we're going to trap this hydrogen gas over the course of a reaction. Knowing the mass of the magnesium, we are able to figure out the moles of hydrogen gas just by doing the simple stoichiometry problem of grams to moles, moles to moles. And so that's the easy part. Now the next part that you're going to do is we have to figure out the pressure of the hydrogen gas. And so doing that, we're going to have to use Dalton's law. And so with Dalton's law, remember Dalton's law is P total is equal to the pressure of hydrogen gas plus the pressure of water vapor. So you probably asked the question, why is there water vapor? Well, this reaction itself is exothermic, and being exothermic, it actually causes the water vapor to partially form in the eudiometer along with the hydrogen gas. So we have to account for that difference, and so we are going to have to figure out how much water vapor is there, subtract that off from the total vapor pressure, which in this case is the atmospheric pressure. And so now the way we do this is, you'll see in the pictures that I have on the file that you found on Moodle, where you take the pressure difference of measuring the height inside the beaker where the water level is, and then to the volume that's inside of the eudiometer. And so you'd have a setup that looks something like this. And so you can have your water on the outside and then you have your liquid inside. So what we do is we measure the height in millimeters using a meter stick going from here to here. So we'd figure out what this distance is in millimeters. And so we would use a conversion factor here of 13.6 millimeters of water per millimeter of mercury. And so you take this height difference, we'll list it as H here, and we're going to take H and you're going to multiply by that. And now H is going to be in millimeters, and so the millimeters are going to cancel out with the millimeters of mercury here, and you'll be given some pressure in millimeters of water. So that will be plugged back into Dalton's law. You then are going to know the pressure in inches of mercury, because that's how we measure it using the barometer. So you'll have to convert this into millimeters of mercury, so that way the units work out. So all you'll do is just subtract the water from P total and you end up with the pressure of hydrogen gas. Now this is at room temp, so we're going to have to work with the combined gas law. Now the other thing that you get from the eudiometer, before I move on here, is the inside here. and this is the volume. And so I'm going to call this V1, for example. Now, next thing we're going to do is we're going to use the combined gas law to determine the volume at STP. And so the combined gas law is P1 V1 over T1 equals P2 V2 over T2. Our goal is to solve for V2 at STP. So that means that here, this is your standard temperature and this is your standard pressure. And so you'll have to look those values up so you know what to put in for those. Alright, so I'm going to put STP here and STP here so you know to look those up. Now what you do know is the P1 comes from the pressure of the hydrogen gas. V1 comes from the volume in the uniometer that we just talked about. And T1 is the temperature of the room. Now remember, make sure you convert your Celsius into Kelvin. And you got to make sure you do the same thing for over here. Also, since the pressure of molar volume could be in atmospheres or millimeters of mercury, you want to make sure that the pressure of the hydrogen gas and P2 and P1 have the same units. So make sure they're either in atmospheres or they are in millimeters of mercury. So again, you're going to solve for V2. Now the whole point of this experiment is to solve for molar volume of hydrogen gas. So to do this, what you're going to do is, well, you did most of the brunt work. Now it's just a matter of plugging this in. So you're going to calculate the volume, V2 up here. So this is the liters, and then you're going to divide it by the moles of hydrogen gas that you calculated earlier. Now there are two trials, so what you're going to do is you'll calculate two molar volumes and then you're going to average those molar volumes out. So make sure you do that, and we know what the actual molar volume is. It's 22.4 liters per mole. So you can figure out the percent error of the molar volume if you want. And let me go back to the lab manual here. Now as I scroll through the procedure here, you'll see here this is where you have the magnesium. You'll see this in the pictures that you see online. And you'll see how I wrap the copper around it. The copper has no mass or anything involved with it. It's an inert substance in this case. It won't react with the HCl. And you can see the distance here. That's the height that I was talking to you earlier about. And here's a conversion factor. So here's another outline of what we're talking about in the video, just an analysis of the data and any lecture notes that you want to write down. So you'll have trial 1, trial 2, you'll average those out. Alright, so the room temperature, the atmospheric pressure, so pay attention to the notes I give you. So here's where the average is, the volume of hydrogen gas at STP. So that's where V2 comes into play, and then you'll calculate molar volume. And then you'll have to use this equation here to determine your percent error. Your percent error is what you actually have, so the value that you calculated, the average, subtracted by the book value, which we know is 22.4 liters per mole, dividing by that. So we want our percent error to be as close to zero as we possibly can get. We know that obviously there's going to be some experimental errors that show up in this, and then sometimes that causes that to be a problem. So we're human beings, can't control that. So, but we can definitely try to explain what may have caused it. So we do have all the necessary information to do that. And so don't forget to answer these questions and the post-lab questions, and you will submit it to me on Moodle as we did in the previous experiment. Thanks.